That should work. Let's see how we go. Alright, okay, let's give it a try. Rolling, Dave? Okay. Well, what I went through last week is the neoclassical economics attempted to reduce macro to applied micro. And the classic view is from Lucas, talking, as they were before the crisis, in a very triumphant way about the economic theory and what it should be. And this is the attitude they had. Nobody was satisfied with ISLM as the end-all of macroeconomic theorising. We, meaning his generation, which gave us rational expectations and so on, was going to combine that with micro, make it consistent with microeconomics. That was their objective. But there's two problems with doing that. One is what's known in scientific literature as constructionism, and that is that even if it is possible to reduce everything to fundamental laws, it's not necessarily possible to work from the fundamental laws to get back where you started. And I'll show you a couple of examples of that shortly. And the second is what's known as emergent properties. Now, I found this is something which comes out of what's called complexity theory. And that's been an area of science that began really in the 1960s, courtesy of research done by Lorenz into weather systems, which I'll explain in future lectures in this series. But it dates actually from 1899, because of the work of Henri Poincaré in trying to solve what's called the two-body problem. But what we get out of this is the idea that when you look at what happens with a number of, if you have, say, a system consisting now of water molecules, okay, you can't define the behaviour of water by knowing how a water molecule behaves. And the difficulty often is when people give examples of this, I find that most of the examples I've seen in the literature of emergent properties don't really make any sense to people. They seem strange. Like the popular one, which I won't give an example of this in this particular lecture, but I'll talk about it now, is what's called flocking. Have you ever seen a flock of birds all flying together? Okay. Well, flocking is said to be an emergent property, and that is if you know an individual bird, you can't work out that the individual bird is going to fly in a flock. But they say if you have a flock of birds together, they move almost like an organic whole. One wonderful video I've seen, you'll probably find it on YouTube if you look, has a group of, I don't know what sort of bird they were, pigeons or some prey bird with a hawk trying to attack it. And you see what they're filming it from a great distance back, and the hawk dives into the flock, and the flock separates. The hawk goes straight through the middle, go back in, dive in, and the flock separates, gets out of the way. So that is the behaviour of flocking comes out of the interactions between the birds. But whenever people talk about that and say that's an example of emergent properties, they think, oh yeah, but you know, that's not really, they'll say the birds are communicating with each other. You know, it's like collusion in a sense. It's not something you can say is a clear example. It doesn't seem to grab for most people. The amazing thing is, I've got a brilliant example of emergent properties for you in economics. And it will explain it completely to you, I think. And I'll go through that in a bit of detail. But I'll start with constructionism. And the person I'm quoting here is a Nobel Prize winner in physics. So he's a real Nobel Prize winner, Philip Anderson. And he made the case, which I went through last week again, is that you can actually say, well, it's quite possible to say physics is the foundation of chemistry, and chemistry is the foundation of biology, etc., etc. And you can therefore say that each of the, for example, everything on the, say in chemistry depends upon what happens in many-body physics. Okay? What happens in many-body physics depends upon quantum mechanics, etc., etc. So you can array the sciences in a hierarchy like that. But that doesn't mean that science X is just applied Y. You said at each stage you need new ways of thinking. So if you're going to do chemistry, it's a wholly new level of thinking, requiring its own rules, its own concepts, compared to many-body physics, even though many-body physics is necessarily the science that describes the entities that make up chemicals. Now, to give you an example there, quantum mechanics is the scientific area that describes the behaviour of elementary particles. So if you want to know what's going to happen with protons and electrons, you need to understand quantum mechanics, to understand what quarks are, etc., etc. Planck's constant, all these various terms are an essential part of knowing what actually happens with elementary particles. And many body physics, at the same time, is described by things like Newton's laws. So once you've got a whole mass of body particles together, like if I threw a, if I drop this piece of paper, the trajectory it follows Newton's laws and gravity and various things about resistance, wind resistance of the particle, what's going to happen there. Maxwell's law will describe what happens in electrons passing through the cable and magnetic fields. Thermodynamics tells you the direction in which energy moves, which is the behaviour of the massive particles interacting with each other, and so on. And general relativity will tell you how space-time curves, blah, blah, blah. But in no way do physicists say, well, because each of these are really based on many body physics, maybe we should go back and try to derive quantum mechanics, derive Newton's laws, Maxwell's equations, thermodynamics, etc., etc., all from quantum mechanics. They are attempting to find ways of unifying them together. But as Anderson himself said, he's somebody who contributes to particle physics, he said, the more we learn about particle physics, the less it seems to make sense to the rest of science. It feels like a completely independent area. So that's a physicist in a far more well-developed area than economics is, saying we don't even bother doing that. But that sounds like a bit of a cop-out frequently as well. Why don't you? Why don't you give it a try? Well, he says, well, if you do, it appears instead that rather than that being possible, wholly new behaviours appear. And understanding those new behaviours at the high level of aggregation requires a whole new level of skills that we don't actually have at the lower level. So if you learn quantum mechanics, you don't learn what's necessary to talk about the interaction of molecules. It's something entirely different. But why is that? Well, we'll get to that in a moment, but this is the sort of division in terms of talking about unifying all these areas together in physics. This is a case in Wikipedia, a little element of saying where they're trying to find a theory of gravity which can be derived from quantum mechanics. But notice what they've got here. Classical mechanics is the stuff from Newton, but Newton gravity as well. Special relativity, which leaves out gravity. General relativity, including gravity. Electromagnetism, which uses Maxwell's equations. Quantum mechanics, all the stuff that Planck gave us. Quantum field theory, QOT, they're trying to devise some overall connection. But each of those areas will be something that somebody specialises in physics. And somebody who does this area doesn't feel that they need to know this area to do it. And nor do they think we have to be able to do this stuff, to be able to do that. They're willing to compartmentalise and say, you can choose to specialise at a particular level. You don't have to know all the others. You don't have to build the higher level from the lower level. Now, to try to make this come home to you, here's a classic instance of emergent property that I think will make sense. And that is that we all know that biological entities like ourselves are actually collections of chemicals that are interacting with each other. So if biologists thought like economists do, in thinking that to do macro, you must reduce it to applied micro, chemists would say, well, you can't do really biology until you can do applied chemistry. Now, that was the case. A typical biology exam question would be, for instance, describe the chemical processes that create life. Okay? That's clearly nonsense, isn't it? Even worse, you might get somebody saying this, your honours thesis, here are the chemicals that make up shown, and this is a bloke who just jumped onto my Twitter feed recently, and I love the way he described himself in his Twitter feed. Here's his self-description. 60 pints of H2O, 18 kilograms of carbon, 7 pints of ammonia, 1.5 kilos of lime, 800 grams of phosphorus, 250 grams of salt, 100 grams of saltpeter, 80 grams of sulfur, 7.59 grams of fluoride, 7.5 grams of fluoride, 5 grams of lime, 3 grams of silicon, and 15 others. So there's your chemical constituents, make them. Obviously you can't do that. You don't even try. So biology is an independent level of chemistry. That, if you like, life is the classic emergent property. We know life comes out of chemical interactions. We have no idea what they are. But we still do biology. We know a huge amount about biology. If we actually did behave the way economists do and said you can't do biology until you can work out the applied chemistry that gives you biology, we wouldn't know a damn thing about biology. So that's a classic instance from another science. So the main reason is the reason you can't do constructionism, you can't work from the bottom level up to the top one, is this idea of emergent properties. And that's back to this statement again. The behaviour of large aggregates is not to be understood by simply extrapolating what happens with one or a few particles. But what happened with macroeconomics under neoclassical development was they tried to reduce the study of the entire economy to a single agent. That's what they tried to do. Now, let's adapt the definition of emergent properties to say, well, that's not possible. Emergent properties, this is taking a definition out of a discussion on a chemistry blog about 2 decades ago, actually. This says, okay, emergent properties applies to a system. A is composed of a collection of entities. So thinking in chemistry, let's say a chemical is a collection of molecules. And it has local properties, obeying rules you can actually use to predict behaviour, but those behaviours arise from non-linear combinations of interactions amongst the entities. In other words, we're now saying the behaviour of chemicals arise from the interactions between molecules, which you cannot reduce to a simple addition of the chemicals with each other. And he said, C, the rules do not depend upon the nature of the entities. So even though you can define the nature of like a molecule of water, that does, of H2O, pardon me, let's use the proper chemical term, hydrogen dioxide, hydrogen. I'm showing I'm not a chemist, aren't I? It doesn't roll off the tongue. H2O. You can't describe water, which is a collection of H2O, on the basis of what individual atom, or molecule of H2O does. I'll give you some examples of that. Of course, we know life is a collection of chemicals. We know it involves chemical interactions. We don't know what those interactions are. That's the point about life being an emergent property. So we can't create life from chemical interactions. Actually, I've jumped. How did I jump? I've got the wrong slide in there. This is great. They're going to go down well on the video. Okay, water molecule. That's what I thought was going to happen. I have to move that slide around later. So a water molecule, isolated water molecule. It's not a liquid. It's not a gas. It's not a solid. It's only when it interacts with other water molecules that you get the states we know as water, liquid, water is a liquid, ice is a solid, and water vapor is a gas. So that's water is a solid, ice, water is a liquid, water is a gas, those three. And it's the interactions between them that give us the peculiar characteristics of water. So for example, ice floats on water. And normally when you freeze something, it gets heavier. Okay? It's actually peculiar that ice actually gets lighter, in a sense, when you freeze it. The reason it does is it's got a crystalline structure. And there's a crystal of ice. And notice there are gaps between them because of the way the hydrogen bonds form. Whereas you do it with the liquid, that's what it looks like. It's denser. So the ice floats on top. So it's only something you can explain by the interactions between the entities, not by the entities themselves. So you must look at the interactions to understand something which is an aggregate of a lot of small individual elements. And the same thing applies with macro. So you've got to know the relationships. You cannot analyse a large aggregation of any sort of system where interactions do occur between the components by leaving out the relationships themselves. But fundamentally what was attempted by particularly the so-called new classical macroeconomists, the ones who derived the whole idea of dynamic stochastic general equilibrium models in the first instance from Robert Solow's model of the growth model, they were trying to reduce the entire economy to one utility maximising agent interacting in one utility profit maximising firm, and reduce the whole of macro to the applied micro as a single agent with no relationships with any other agents. So that's the irony. It simply was mad to even attempt to do it. But the interesting thing is, neoclassical economists proved that it wasn't possible long before they tried to do it. And this is where I find the education or indoctrination of neoclassical economists so frustrating. They do not learn their own literature in anything like a complete whole if they did, there wouldn't be neoclassical economics. They would long ago decided it was a dead end, but to do something else. Now, the clear instance of emergent properties in economics comes out of what's called the Sonnenschein, Mansfeld, de Broglie conditions, the names of the three people who are regarded as having discovered this. So, in fact, we have another guy called Gorman, and I find this bizarre. This proof that you couldn't do what DSGE models attempt to do was actually first shown in the year of my birth, 1953. Decades before these neoclassicals went off and tried to do what was impossible. Now, if you go back and look at Solo, his critique of DSGE models last week, we had this punchline: how can anyone expect a sensible short to medium term macro to come out of that setup? He rejected the proposition that macro had to be applied micro. And one of the reasons he did reject it was this. He said, suppose you wanted to defend it. The Ramsey model, by the way, is the growth model of the Ramsey-Solo growth model. They're both involved in devising neoclassical theory of economic growth. And he said, well, what could you say to defend attempting to use this growth model as the basis of macroeconomic theory? He said, I take it for granted realism is not an eligible defence. There's nothing realistic about it. We said, well, you could claim that there's no other way to do it and still meet the claims or the requirements of economic theory. And I've bolded with his main statement there. That claim is a delusion. This is a Nobel Prize winner in economics now, saying that what neoclassical economists are doing in macro is delusionary. Not some left-wing radical. His starting point for that is we know from the Sonnenschein Mantel theorems, we know something from them. And he says the only universal aggregate of implications for general equilibrium are that excess demand functions are continuous and homogeneous at degree zero and satisfy Roll-Rise law. And I'll talk about a few of those later on. He said anything else apart from that you can't derive from micro itself. So you cannot derive the proposition, for example, that a single agent represents the entire economy. Okay? You're adding that to yourself. That cannot be proven from the theorem. So we have to know what these conditions are. And they start from the idea of what's called the law of demand. Are you all familiar with the law of demand? Okay, the idea that if you're going to sell more of a commodity, you've got to reduce its price. Sounds nice and easy. Well, strictly speaking, what that law actually says is what's called the Hicksian compensated demand curve must slope downwards. You know what Hicksian compensated demand curve is? You heard of that one at all? Hicksian? Okay, most of you have. I'll go through it anyway for the sake of those who are watching. That's laws that arrive for a single individual consumer, isolated consumer. And it's necessarily a law, starting from the definition of how an individual consumer behaves. Does it apply to a market? In a nutshell, the SMB conditions say no. Instead, what they conclude, and I'm using a good reference here to point out that the way it's conveyed in books like Berry and Co. is not accurate, that any polynomial curve can be a demand curve. So any curve you can describe by a function a plus bx plus cx squared plus dx cubed, etc., etc. Anything you can fit by that can be a demand curve for a market. And here's the statement from Sonnenschein's research. Can an arbitrary continuous function be a demand function for some commodity in a general equilibrium economy? In other words, when you draw a squiggle on a piece of paper, can that be a legitimate demand curve? Now, you'd think from all the stuff you've done in micro, the answer would be no. That the squiggle doesn't necessarily slope downwards. But he says, yes, we prove every polynomial is an excess demand function for some specified commodity, some end commodity economy. So as soon as you generalise beyond a single consumer consuming a single good and ignoring the impact of changing the price of that good on the income of that individual consumer, as soon as you generalise as there's more than one consumer, you find that any old squiggle will do as a demand curve, not the downward sloping line anymore. So every continuous real value function is approximately an excess demand function. That's from Sonnenschein from 1972. Now, let's look at what the law of demand is supposed to be. It's an economic law that says consumers buy more of the good when its price decreases and less when its price increases, other things held constant. At least if got ceteris paribus in there, they do not admit in the definition from the Wikipedia that the SND conditions are nice limitations on the law of demand, I might add. I'd like to see somebody go inside and edit that, thanks very much. How is this derived? Well, it's derived by taking an individual, I'm emphasising that, individual consumer utility function. You presume you can describe a consumer as using the axioms of revealed preference. You get all the smooth, differentiable function to describe that particular agent's demand for commodities. You need to derive a demand curve from it. And of course, the curve you first of all derive by keeping income fixed, keeping the price of one of the commodities fixed, or the price of all of the commodities fixed, and varying just that one. That's going to give you a combination of both the substitution effect and the income effect. So the Hicksian procedure is supposed to remove the income effect and leaves you just with a pure substitution effect, and that necessarily obeys the law of demand. So here's the basic procedure. You start with, first of all, having a rational consumer, as neoclassical economics defines rational. I'll get back to that shortly. And you then have an indifference curve that says, here's all other goods, and let's look at the rational consumer's demand for bananas. There's an individual, and that's a set of curves that define that individual preferences for bananas versus all other goods. And then you say, well, let's try a few different prices for bananas. We keep the income constant, so this particular point on the pivot doesn't change. Okay? And then you say that's a very expensive price for bananas, a cheaper price for bananas, and a really cheap price for bananas. And we then work out the points of tangency between the budget line and those indifference curves. And we drop down, now giving the price information we have, drop the quantities down, check whether they intersect with the prices we've put in beforehand, and there we have a downward sloping demand curve. But it's quite possible if I'd drawn those indifference curves differently, I could have that curve sloping backwards because the substitution effect, bananas could be really undesirable products, unlike the current advertising on Australian media. You can see all those banana ads everywhere at the moment. They could be really undesirable, so as the price of bananas falls, you might eat less bananas and more of other things, because the income effect can outweigh the substitution effect. There's an individual demand curve with the dilemma, however, that given those undesirable goods, which economists call Giffen goods, you could actually get the reverse relationship. The demand curve could slope up as the price falls. Now, the way to get around that is to say, let's go for a Hicksian compensated curve of will, where John Hicks is the person responsible for this idea. So you start with an initial budget line, double A, I'll show it in the diagram in a moment, and the consumer will therefore consume combination A on the indifference curve X. So just to point that out on screen, there's combination A, there's the budget line A, big A, little a, little a. The point of tangency is with A at this point here. Then you have a new relative price, AB, which is out here somewhere, giving a different point of tangency to a higher indifference curve out there. So both the psychic income of the consumer has increased because you've reduced the price and they can buy more of everything, including bananas. What you then do is you move that curve backwards, keep it parallel, and get a new curve CC that's tangential to the old curve. And necessarily, point C is further down, further out. Okay? It would be possible to draw that so that point B was actually behind point A. I haven't done that in a particular diagram, but by doing that, what I show is that the substitution effect alone means even an undesirable good like potatoes, if you keep a person's real income, psychic income constant by keeping them the same level of utility, then you drop the price of potatoes, they'll eat more potatoes, necessarily. That's the law of demand. And it requires the Hicksian compensation process to work. Now, what's actually happening is you're holding the income constant by keeping them in the same indifference curve. And therefore, the budget line necessarily flattens as you reduce the price. Okay, it's basically giving you the tangent to that indifference curve, and therefore it necessarily slopes downwards because using the axioms of real preference to begin with, that's the shape that indifference curves must have. That applies for a single consumer. Here we go. You do this, and then you get rather than the single point. Now we're doing this rotation, fitting the shape, fitting the slope of the indifference curve. Necessarily, it's going to give you points that are further out each time you drop the price. So that guarantees you're going to get the result you like, have a Hicksian compensated demand curve that actually slopes downwards. Whereas one without the income effect, or rather with income effect as well, could actually slope in the wrong direction. That's true for individual demand curve. What about plural? What about more than one consumer? Well, the conclusion of the SMD conditions, Sonic mental reverse, SMD is much easier to say than that, is the law of demand fails aggregation. If you have an economy with multiple consumers who individually do obey the law of demand with respect to every commodity you present them with, so they've all got downward sloping Hicksian compensated demand curve. None of them are irrational, as neoclassical economists define irrational. It'll result in markets in which none of which the law of demand necessarily applies. By accident, you might get some that do, okay? But even working from neoclassical starting points, and even without bringing in production issue, you're just looking at an endowment economy where everybody has, Robinson Crusoe and Man Friday turn up on an island and all the stuff they can actually consume is already sitting there. You don't get a downward sloping market demand curve. So, to go through why that happens, if you're going to have multiple products and multiple consumers, then obviously utility functions of the consumers must differ. Because if I say, you two have both got the same consumption utility function, you're the same person. Okay? So to have more than one consumer, you must have different utility functions. And equally, it must also be the case that the Engel curves change with income. Now the Engel curve, you know what the Engel curve is? Remember that one? It's the curve that supposedly describes how your consumption changes as your income changes. Now that curve is a straight line. Then you're only working with one commodity. Because the only way you could ever not change your consumption patterns at all as your income rose would be if you're eating spam, drinking spam, watching spam, etc., etc. Okay? You just get more spam. So you simply have to have variation, otherwise there's only one commodity. Okay? There's got to be spam versus which is obviously not a necessity, which you don't want to consume, and wine and pizza and television, etc., etc. So your consumption will vary as your income level changes. Those are your pre requirements. Now, here's the first time it was actually this result was ever found by Gorman back in 1953. As I said earlier, we will show that he was actually working trying to derive the utility function describing an entire society, which actually is exactly what the neoclassical DSGE models do today. And he said that is possible if, and notice the condition, if and only if the Engel curves for different individuals at the same prices are parallel straight lines. So back in 1953, he said only if that condition applies can you derive a utility function that describes an entire society. But even that's not as bad as it actually really is. What does he mean? Well, he's trying to derive a single utility function for an entire economy, which, as I've pointed out, is exactly what DSGE models thought was okay prior to the financial crisis. And he proves you can only aggregate those if all the individuals are the same individual and all commodities are the same commodity, which, of course, is not aggregation at all. It's proof by contradiction. Has anybody here seen what proof by contradiction is before? We've done my lectures, you've got it back in behavioural finance. What is proof by contradiction? Well, it's an ancient technique to prove a mathematical proposition that you can't otherwise solve, where you assume something is true. For example, you assume the square root of 2 is a rational number, and you then follow through the logic and you contradict that assumption. And by having contradicted your initial assumption, you prove that the square root of 2 is not a rational number. Now, the first time this was recorded as having been done was when the Pythagorean mathematician, back in the days of Pythagoras in the Greek, I think about 350 BC or something like that, proved that the square root of 5 was not a rational number. And the way he did it was using pentagrams, 5-sided objects. And he had a pentagram where you could get a particular, and you then could draw points from the inside the pentagram, and from those points get another pentagram. And then you've got triangle relationships turning up as well, and you could work out proportionality ratios between various lines. And he proved that if you kept on going, you do one pentagram, another one inside that, another one inside that, getting smaller and smaller and smaller. And he proved that those ratios did not remain constant, which meant therefore you couldn't find the relationship between each of these lines, the lengths of the lines, could not be described by one integer divided by another integer. You couldn't define it as a rational number. Now, the Pythagoreans, when they began, one of their defining arguments was that all numbers are rational numbers, meaning you can divide one integer by another, and that will be equal to whatever number you're talking about. Now, I've mentioned in the book, I haven't unfortunately got the copies of the book yet. I'll get that next week, I hope. Dave, you got the order in for the reading? Okay. When he proved that, he was unfortunately on a boat in the Mediterranean. And when the result was proven, his colleagues then promptly drowned him. As best we know the history. So they didn't particularly like finding out that result. But of course, at a later stage, they accepted that irrational numbers existed. And then, if they hadn't decided that, we wouldn't be living inside, a building like this watching a data projector, because that's the beginning of the mathematics that gave us the understanding of the very complex world in which we live. But I'll take you through how it works. So you say, if you assume that the Pythagoreans did that all numbers are rational numbers, then you can start by saying, is the square root of 2 a rational number? Well, if it is, there must be two numbers, integers, a and b, which are the smallest numbers for which the following statements are true. That a over b equals the square root of 2. That must be, if the square root of 2 is a rational number, then there must be two integers, which are the smallest possible integers, which are a over b equals the square root of 2. Obviously, there's one which is 3 times a divided by 3 times b is also going to be equal to the same thing. We're talking the very smallest one you can get to, and still have a and b both being integers. That must be true, if that's correct. So you start with this proposition that a and b have no factors in common apart from 1. Okay? That's the only factor they've got in common. And then you assume that this is true. Well, you then work by your logic and say, let's square both sides and see what happens. We get a squared over b squared equals 2, which we can rearrange to say a squared equals 2 times b squared. And that tells us something about a. It has to be an even number, because if a squared is 2 times b squared, okay, 2 times any integer, odd or even, has to be an even number. So a has to be even. So having done that, I can now say a squared, a is 2 times some other number, for example, c. A has to be equal to 2 times c, because it can't be an odd number. Otherwise, squaring it would give another odd number. So a is 2 times c. And if I then look at what a squared is therefore 2c squared, which is 4 times c squared. And I substitute that back into the first equation for a squared above. And I've now got up there that a squared, which is 4c squared, is now equal to 2b squared. So having done that, if I divide the last bit by 2, I now find that 2 times c squared is equal to b squared, which tells me that b is an even number. A logical contradiction. I've actually started by assuming a and b have no factors in common. Starting from that assumption and following through the logic, I've now proven they're both divisible by 2. They've got 2 in common. There's a common factor. Therefore, my starting assumption must be false. It can't be the case that a over b is equal to the square root of 2. So by proof by contradiction, you've proven that 2 must be an irrational number, a number that cannot be defined as a ratio of 2 integers. That's the idea of proof by contradiction. And they didn't like it, but they were forced to accept the logic, and that's how mathematics evolved as dramatically as it has since 350 BC. But economists are keeping us back in 350 BC in economic terms by having exactly the same belief that rational consumers, if you add the demands together, gives you a rational market demand curve. when in fact they've proven that adding rational consumers together gives you an irrational, wobbly market demand curve. That's the fallacy. So if you look at the conditions that they then say are needed to derive a down-sloping market demand curve, they actually contradict the assumption that you have different consumers of different goods. But they haven't reasoned it that way, and it's what I find quite appalling about neoclassical theory in general. They are so resistant to anything which challenges their foundation beliefs that they distort the logic and can't even see what they've actually done by deriving this very, very accurate result. So here's our operation for an individual consumer, which you start from before you can fix in compensated trick. That assumes that changing relative prices doesn't alter the income because you remain at this pivot point. The income is represented by that point there, that doesn't change. Now that's okay for an isolated consumer. If you're considering a single consumer and trying to derive that consumer's demand curve, that's all right. But you can't do it for more than one consumer, because then prices are the sources of incomes. Again, a major part of neoclassical economics is say the price system determines income. So price times the quantity, whatever you're selling determines your income. And if you change prices in a general system, you're going to be changing somebody's income. So you can't ignore that when you go to the multi-consumer world that we actually live in to try to derive that demand curve. So what Sonish and Mandrel concluded that market demand curves don't obey the law of demand, even if you're summing up well-behaved demand curves. So you have Crusoe with a downward-sloping demand curve of bananas, and Friday with the same, you add them together in a demand curve of bananas and look like the wobbly line. And it's all quite legitimate. So here, let's go through it from the point of view of proof by contradiction. They start by assuming the market demand curves do obey the law of demand. And they then derive the conditions under which that's true. And they can contradict the initial starting point of assuming you have two consumers with different tastes consuming different commodities. So that's what it really is. It's proof by contradiction that market demand curves don't obey the law of demand. And therefore we should have a totally different way of analysing markets than neoclassical theory does for micro, let alone analysing the macroeconomy. So going back to the starting point, deriving the individual condition ignores the impact of price changes on income. But of course, those price changes will change income. So let's start off, how do we set out the initial conditions? Let's say we assume that market demand curves do obey the law of demand. Then we have to say, how do we define multiple consumers and multiple commodities? Well, to have multiple consumers, then we have to have different sources of income and different tastes, otherwise there's just one consumer. And the taste must change with income, otherwise there's only one commodity. So let's say we're looking at a two-consumer, two-commodity world, as simple as it can be. Got Robinson Crusoe and Man Friday. And they've got coconuts and bananas that are on the island they exist upon. And Crusoe owns all the bananas and Friday owns all the coconuts. Now, let's get a slightly less abstract here. We might say Crusoe's the capitalist and Friday's the worker. We now put up an income distribution, which is what all this comes down to mattering about. Well, let's go back with a little example here. Crusoe, banana owner, Friday, coconut owner. Coconuts is a necessity, bananas are the luxury. And Friday, as it happens, has a higher preference for coconuts than Crusoe does. Let's start with an arbitrary price ratio. Here's the coconuts versus bananas demand for both of them. There's Crusoe's indifference curves. There's the budget line for both of them. And I'm going to keep aggregate income constant. So there's no change in the number of coconuts or the number of bananas on the island. That's remaining constant. And you consider a lower price for bananas. What's going to happen? Well, the lower price for bananas, you flatten the slope of the curve. But Crusoe owns the bananas. So his income's going to fall. And relatively, Friday's is going to rise. So when you take a look at it, what now happens when you consider this new ratio, that's what happened to Crusoe's income. But Friday's is increased. But there's no change in the absolute number of the two commodities on the island. So market demand for bananas can fall because the price of bananas has fallen. Because Crusoe's income has fallen, he's one who gets income out of the bananas. Friday's income rises But Friday doesn't like bananas as much as Crusoe does. So the demand for bananas could fall because the price fell. Now, if you try to keep relative prices constant in the Hicksian procedure and increase income equally, you can't do that either, because we start from this position and you try to move the curve out to represent an increase in the number of bananas and the number of coconuts in proportion to each other. What's going to happen, because the bananas are luxury, demand will rise more for bananas than it will for coconuts. So if you do that, because Crusoe is the person who owns the bananas, he's going to rise by more than Friday's. So you'll redistribute income simply by increasing the number of, in perfect proportion, increase the number of bananas and the number of coconuts in proportion. You'll actually cause the distribution of income to change simply because the tastes of two agents are such that one commodity is a luxury and the other is a necessity. So you can't compensate for the income effect of a price change as you can with an isolated individual. You've got yet another limitation of what you can do. So a uniform increase in income alters the distribution of income because of tastes being different. Because one item is a commodity, a luxury, the other is a necessity. Increasing the proportion benefits the party who produces the luxury, even though you're keeping the number of items in strict proportion to each other. So the outcome is that particular pivot point that is fixed in deriving it for an individual is bouncing all over the place, up and down for both agents. You're adding it all together and you get any old curve you like. You can define that way by adding the two points together. So the only way you can avoid it is by assuming that all consumers have identical tastes, which means there's only one consumer. And you assume the tastes don't change with income, which means there's only one commodity. So you've contradicted your starting point of two consumers with different tastes consuming two different commodities. So it's proof by contradiction that the law of demand doesn't apply. This is actually an example of proof by contradiction rather than actual proof in that way. It'd be lovely to have somebody try a PhD thesis, which you would probably take, where you actually defined it properly and set it out in our proof and rederive this astonishing and angle degree conditions of proof by contradiction. That's what it really is. Now, what the way neoclassicals in fact talk about it is they say these are the stringent conditions necessary to achieve aggregation, which is a bit like saying the stringent conditions under which you can draw a right-angled triangle, where you are not allowed to draw a right-angled triangle where the non-hypotenuse sides are both 1. We ban that because that'll give you the square root of 2. Can't have that. So the stringent conditions are we rule out the existence of all numbers that aren't rational. That's what they're really doing by saying stringent conditions here. So to obey the law of demand, this is how it was put by Schaeffer and Sonnenschein, who are actually probably the best in terms of how they express it. They say the law of the market demand curve will obey the law of demand when preferences are homothetic and the distribution of income is independent of prices. Now, the last one I should claim for you, because one reason that neoclassical economics try to say it's better than later theory of value or all the other theories of economics is to say, well, we take account of how prices determine incomes. Well, here saying independent of prices. That's pretty crazy. Preference is homothetic. That sounds really scientific, doesn't it? It means they're all play the same. It's just amazing. Gorman put it this way. If and only if personal Engel curves are parallel straight lines. Now that actually, even that sounds better than it is, because of parallel straight lines, that could be Dave's Engel curve, bananas versus coconuts. That could be Steve's, parallel to each other. And with one slight logical problem. They both pass through the same point, because the theory presumes you only can consume if you earn an income. So if Dave and Steve both have zero income, both those parallel lines pass through the same point. And any parallel line passing through the same point is the same line. Okay? They haven't even thought that through properly. So it is quite crazy why the little confused man turns up all the time. So Engel's curves, just to reiterate why that's the case, Engel's curves are supposed to show how consumption changes as income changes. And there's three possible cases: a luxury where consumption rises with income, a necessity where consumption falls with income, and a given good where consumption falls absolutely, an undesirable good. So here's a basic drawing of them. Graphically, that's a necessity. There's all other goods, there's your bananas, and as your income rises, you consume less bananas compared to everything else. So the curve slopes away. A luxury, there's your difference curves, increase your income, your consumption rises compared to other commodities. Inferior good, it actually bends backwards. There's your changing income, your consumption patterns bends backwards that way. Now there are no commodities that look like this. The one that Gorman actually said does apply, this. They've got to be homothetic or neutral. Neutral means here's your indifference curves, there's your change of income, that's your consumption pattern. Straight line. Now, to give us some sort of way they would actually apply, imagine if you consume one pizza, one Coke, and no Rolls Royces a day when you're earning $100 a day. If your income rises to $10,000 a day, you consume 100 pizzas, 100 Cokes, and no Rolls Royces. I'm sorry. Now, people are going to criticise me not having marginal. Even if I take the marginal change, I still get the same result. That's a perfect. Just a bit of example. The ratio of your relative consumption does change with income. Imagine what Bill Gates would be consuming in the way of toilet paper rolls now if his consumption had just increased proportionately from when he was, a struggling nerd to when he's an extremely wealthy nerd. He wouldn't be able to get enough containers on the road taking toilet paper rolls on a daily basis. It's just stupid. But it says it's even more stupid than that. Saying it had to be parallel. So here's Joe Bloggs. There's his indifference Engel's curve. There's Bill Gates, also the same slope. But they're both passing through zero. And one of the definitions, the way you define the same line, say parallel lines passing through the same point are the same line. So therefore, it's not a case of saying that they've got parallel preferences, they have exactly the same preferences. There can only be one individual. So you get this bizarre situation. It's proof by contradiction. I'm going hammering this because it is so crucial in neoclassical economics. And it actually doesn't just rule out macro, it rules out micro as well. So that's what economists draw. Individual demand curve sloping down, market demand curve sloping down. This is more valid. Individual demand curves, yep, no problem with the theory. Aggregate, what you get looks like that. Now, of course, with a market demand curve like that, you can't do equilibrium analysis. Even if you could draw a supply curve through it, and I'll talk about that in a short while, even if you could, which point of intersection would you choose? There is no longer an easily definable point that you can say is going to maximise social utility if that's the point that it ends at. So you get that result. The conclusion should have been that supply and demand equilibrium analysis can't be done. Something more elaborate than that is necessary, even if you start from a neoclassical vision of how individual consumers and individual firms operate. Therefore, Marshallian micro, I'm using Marshall loosely here, by the way, as Neil Parker will tell you, of course, it's Neil. What they call Marshallian economics is not Marshall's elaborate theory, but the footnotes give his principles. So Marshall doesn't deserve as much opprobrium as people who bastardise his theory do. But it certainly means you couldn't even do supply and demand analysis. That'd be out. And if you did macroeconomics, of course, there's absolutely no way you can model the entire economy as a single agent. But that's precisely what neoclassical economics does. Now, the logical way to think about this is say, well, we simply can't aggregate everybody. Simply cannot do that. We've proven that's impossible. But maybe you can aggregate similar individuals. Maybe you can say all people who earn their income from a particular pursuit. We can lump those together. And that really restores the classical approach to economics, where you talk in terms of social classes, rather than talking in terms of isolated individuals and methodological individualism, as neoclassical economists call it. So it's actually reviving the classical school of thought. This is how Alan Kerman interpreted it.
in one of the very few very good reactions to this result amongst people who were once neoclassical economists. I've moved a long way from that now. He says, if we are to progress further, we may well be forced to theorise in terms of groups that have collectively coherent behaviour. That is talking in terms of social classes. So ironically, even though neoclassical economics was devised to try to destroy the classical school, by properly following through their own logic, it concluded the classical school was right to work in terms of social classes. He says demand and expenditure must be defined at some reasonably high level of aggregation. The idea which is started at the level of the isolated individual is one we may well have to abandon. I wrote that 20 years ago, 20 plus years ago. And he's been a voice in the wilderness all the way through. Why is that? Why don't students learn this? Well, let's look at how it's communicated in textbooks. If you look at a quality work like a Handbook of Mathematical Economics, which I think Arrow and Trilligator were the editors of that, and they got Schaefer and Sonnenschein, who did the original research, amongst some of the original research, also DeVries in there as well, and Mansell. And they conclude in this document, which should be the sort of thing you'd expect your lecturers to read, market demand functions need not satisfy in any way the classical restrictions, by which they mean the law of demand. And said the importance of the above result is clear. Strong restrictions are needed to justify the hypothesis that a market demand function has the characteristics of a consumer, which of course include the law of demand. That only in special cases being, where you're not allowed to consider irrational numbers, effectively, if you're a mathematician, will it act as an idealised consumer? And then punchline, the utility hypothesis tells us nothing about market demand, unless augmented by additional assumptions. That's the point that Solo was making when he said what we know from the SMD conditions. Okay? So you not only can you not base... Come on in, just that. This is a colleague... Thank you, Ed.
I'm really sorry.
No problem. This is Jasper, a colleague from Oxford University, who's out here, and this is Ed. You all know Ed. You're not going to be on YouTube shortly, mate. At least.
Yes. You.
Yeah. Okay.
I'll watch it.
Thank you for bringing Jasper in. Okay. So that's the honest statement of the Sonnenschein-Mandel verb conditions. What you get in postgraduate textbooks is, it's polite to call it dishonest. Here's variant. I think I mentioned variant is what you got for micro this year, isn't it? You'll find this statement, I've actually got the page and considered it is in debunking economics. It is sometimes convenient to think of aggregate demand as the demand of some representative consumer. The conditions under which this can be done are rather stringent, but the discussion is beyond the scope of this book. In other words, too tough for you guys, we've proved it's okay, no need to worry, nothing to worry about here, please move along. Okay? Distractionary work. That's variant from 87, on page 268. A more recent reference in 1992 changes it from saying, actually look at the second edition, which is the 1987 one, I think. It says its demand function, which is where you have an aggregate consumer, can be rationalised by a representative consumer. But even though rational is a positive word, we all know that saying something rationalised means they're bullshitting themselves, okay? Well, he edits it for the third edition, and he edits it to be the word generated, which sounds much more reasonable, doesn't it? It's obfuscation of the first order. And undergraduate texts are even worse. I set this as a question for my first behavioural finance class about 3 years ago, I think. I said, I want students to go and take a look at textbooks and see if they can find anyone who discusses the problem of aggregating from a single consumer to a market. And most of the cases, of course, there wasn't, but they found a few where there were. And one is Sloman and Norris from Macroeconomics, the second edition, the Pearson book. This would be, I think Sloman is the Australian and Norris is the American book modified. But down page 45, demand curve, talking about how you get the market demand curve, you add up total demand of all consumers in the market for any given price, which implies you can do a horizontal aggregation, which is ignoring the impact of the price changes, varying the incomes at the aggregate level. No mention of the problem at all at that level. My favourite is Samuelson. And this was Samuelson and Nordhaus being the two American authors of the definitive textbook of neoclassical economics. Paul Samuelson's PhD thesis effectively became the basis of textbooks in economics ever since, I think, 46 when he wrote his thesis. And this is edition 19. That's how many editions it's been through. Every textbook is a clone of Samuelson, just by making it simpler and simpler every time along. And this is what a student found for me, saying the market demand goes down by adding together the quantity demanded by all individuals at each price. And now, does it debate the law of downward sloping demand? Exactly the question I'm raising with here. Boom, it certainly does. And I saw that and thought, what total bullshit. And here he goes, price drops, the below price attracts new entrants with the substitution effects. Now he talks about income, he's actually hedging his bets if the income and substitution effects are combined. But he's definitely very confident that the law of demand is obeyed by an individual market demand curve. So I found that, the students found that out for me in 2010. And when I wrote the debunking towards the end of the second edition, towards the end of 2010 and beginning of 2011, I thought, surely Samuelson's not as dumb as some of the other textbook writers. Surely he knows of the Sonnenschein-Mandel revert condition. I simply couldn't believe that he was making that mistake. It had to be Nordhaus making it rather than Samuelson. But I thought I'd check Samuelson's research. Well, I did, and what I found is the following. In a research paper, which I'll talk about in a moment, he admits the problem. He says, what defence can we make for using community indifference curves, which is the stuff that Gorman did back in 1953, for a country or a group of individuals? How can we try to represent an entire country as a single set of indifference curves? He said, we might claim, notice this, a country is inhabited by a number of identical individuals with identical tastes. And said, and also identical initial endowments. We're admitting all the problems that I've shown you exist in the actual. He knows the literature at this stage. He said, that's pretty unrealistic. Can't do that. However, he said, what about a family? Well, you must have a pretty good family. Lighter, thicker than water. So the preferences of the members of the family are related to what we might call a social welfare function, taking into account the deservedness of each member of the family. And therefore...
Germany in the 1930s.
Pardon?
We tried that in Germany in the 1930s.
Yeah, it worked pretty well, didn't it? Yeah. And don't forget Pol Pot. Okay. So the family acts as if they were maximising a joint welfare function. And notice to do that, mum and dad have got to come home and allocate their income amongst the family so as to give the marginal social significance of every dollar equal in the family. Yeah, I know. You've got to shake your head, haven't you? And then he says, now this is what I really love. Then he assumes the entire American economy is one big happy family. And I'm not joking, I wish I was. The same argument will apply to all of society if optimal reallocations of income can be assumed to keep the ethical worth of each person's marginal wealth equal. Can you believe this stuff? And he then says a rigorous proof is given that this community indifference curve has all the properties of an individual one, and therefore you can do everything we've been doing so far in neoclassical economics. So America, if we assume it's one big happy family where they redistribute income prior to trade taking place, you can describe it with a single indifference curve. I mean, God, I'd like some of what he was on. I mean, I haven't been to a party that good in decades.
America is very well known for being very carefully distributing income.
Oh, it's so, it's such a wonderful, harmonious society, as we all know. Yeah. Now, ironically, this garbage gets repeated as research. I'm sorry, this is, if he's alive in a room, I'd say it's garbage to his face. And the textbooks repeat it as if it's sensible. And now you're very lucky you're doing an honours degree, because if you're doing a PhD, you'd actually have to read another book, not variant, but one called Microeconomic Theory by Mascarell and Friends, who's a Spanish economist, neoclassical economist. And here he's saying the same problem for PhD students. When can we compute meaningful measures using the same techniques we use for individuals? He said, where there's a fictional individual whose problem when facing society's budget set is the same as the entire society's. But he said that's not enough. not only do you have to generate one individual who represents the whole of society, it actually has to represent the ethical judgments everybody makes in society about everybody else. Now, how do we do that? Well, simply, let us just assume that there is a process, a benevolent central authority perhaps, that for any given prices in wealth distribution, redistributes wealth in order to maximise social welfare. Then we can get a downward sloping market demand curve. So if we hand over to, a couple of well-meaning individuals like, Adolf Hitler or Pod, Joseph Stalin, they can redistribute for us and we'll get a market demand curve in capitalism that slopes downwards. Isn't that a good idea? Now, the thing I find bizarre is this stuff is actually published in the textbook. Now, that's one advantage. I've got to give Maswell some credit there. At least this garbage is actually published and accessible to students in the textbook now. But he doesn't realise it's garbage. He actually quotes that Samuelson paper and says that's for more detailed reading, please look at this research paper. Without taking a look at saying, you have to assume that there's a benevolent central authority redistributing wealth in a capitalist economy before you can have trade and have a downward sloping market demand curve. That's madness. That's how desperate they are to hang on to this result of being able to say that adding rational consumers together gives you a rational market demand curve. So they've proven, ironically, that the SMD conditions have proven that macro cannot be applied micro. And yet that's exactly what they've done. So again, they're ignorant. Neoclassical economists are ignorant of their own literature. So this is why I say it's a classic instance of emergent properties. You've got a whole bunch of individual agents. Your market is made up of a whole bunch of consumers. Defining the consumers, you get downward sloping market demand curves, individual demand curves for each of them. Aggregate, you get a wobbly line. Okay? And that's the classic instance of emergent properties. So I think that's, ironically, even though economics have been most resistant to complex systems thinking, they've got the best example of emergent properties outside biology. Or I can say, if emergent properties didn't apply, chemistry would be applied, biology, and you get exam questions telling you, please make this human being in this set of chemicals, including saltpeter. So the whole ambition of having a micro foundation for macroeconomics was false from the very beginning, before it even began. But the interesting thing is, well, even if micro were correct, you couldn't derive macro from it. But micro isn't correct. Let's take a break there and do that in the second half of the lecture.